Alright, so moving into 7.2, this is working with confidence intervals and finding the different kinds of confidence intervals, giving different sets of information. So for the first one, looking here, express the confidence interval of 0.111 p is less than p, which is less than 0.555, in the form of p hat plus or minus e. So basically, I gave you what these formulas are. So for p hat, and I'm sorry that this is so small. I'm going to zoom in here now that you have this information. Alright, so we need these two numbers right here. I'll zoom back out when we read the next question. Alright, so we need p hat and we need e. So p hat is just your upper, and actually I'm going to redo this. I'm going to do upper confidence, lower confidence, p hat, and e. Okay, so the upper confidence is 0.555 and the lower confidence is 0.111. I just pulled that right from the problem. So p hat is your upper confidence limit plus the lower confidence limit. So I'm going to put this in parentheses, upper plus the lower divided by 2. And then your e is going to be equal to your upper minus the lower divided by 2. And then you just express it in the form that it gives here, p hat plus or minus e. And so basically you'll just type these two numbers into Pearson. That's all you have to do. I know it seems like super innocent and super simple, but that's literally it. For this next one, it's asking you to express it in this form here. The p hat minus e is less than p, which is less than p hat plus e. Literally type in these two numbers. So this number here, I'll put it underneath, is 0.056. This number here is 0.112. It just gave it to you as a coordinate set rather than your inequality. That's the answer. I promise you. Type it in. It works. Okay. Moving on. This is a super simple section, and I hope you guys are enjoying it because of that. Use the given data to find the maximum sample size required to estimate a population proportion or percentage with the margin of error of 0.08, the confidence level of 95%, and your p hat and q hat are unknown. That's totally fine. We can still solve this problem. I'm going to zoom in because all of the information we need is at the bottom. So your margin of error, which is e, is 0.08. I'm just setting up a table like I have been for the past few sections. Your confidence level, CL, is 0.95. I'm just changing that to a decimal rather than a percentage. So we're looking for n. That is what we need. All right. So we need a little bit more information on this. So we're looking for a sample size. We have our error. We have our confidence level. We actually also need our z-score. As you can see, because it says z sub alpha divided by 2. Whoa. Okay. So you're going to do 1 minus the confidence level, and because it's divided by 2, you divide it by 2. So 1 minus your confidence level divided by 2. There you go. That's the z. So then you have your critical value. Oopsies. Critical value. And your critical value is just the normal inverse, and you're going to use the z value. So norm.inv equals norm.s.inverse, and then you use your z. And it gives it to you in a negative number. So here's how you do to fix that, because you always are going to have this as a positive number typically. So you're going to do -1 times, and it'll give it to you as a positive number instead. So the next thing that you're going to do is you're going to be able to find your n. Oops. Okay, so then you have your n. This is what you do because you don't have p hat and q hat known. If you had p hat and q hat known, this would be a lot easier. Alright, so you're going to do this formula. So you have your numerator. So you're going to do z squared And then it's going to be times, and I'm going to actually put this in parentheses because I am the parentheses guru. So we're going to have lots of parentheses. 0.25. And I use the 0.25 because 0.25 because that's what it says to multiply by in my formula. Then I'm going to divide by my error, which is also my critical value, and I'm going to square it. So in all reality, this is like 0. If I just kept going out or like rounding it off, it would be 0 because it's 0.05. So it would be either negative or 5, so it would be 0.0004004, 0.0004067, something like that. So it's 0. That would be your answer for this one. If p hat and q hat were known, then all you would have to do is you would still need all of it, basically. Except this top, the 0.25 changes, you would multiply by p hat and then by q hat instead of multiplying by 0.25. So that's how you find your maximum number. And that is 7.2.